Lesson 2.8, Literal Equations. A formula or equation that involves several variables is called a literal equation. To solve a literal equation, isolate the indicated variable to one side of the equation using inverse operations and all other terms to the other. Okay, let's look at number 1. Copy it down, please. 4m minus 3n is equal to 8. And so this equation, we're going to solve for m. M is the variable that we want to isolate on one side of the equation, and there's m. Okay, so let's look at m and figure out what is being done to m. There's two operations happening there. It's being multiplied by 4, and 3n is being subtracted from it. So let's go ahead and start by reversing or doing the inverse of the subtraction. We'll start by adding 3n to this side. That will eliminate that minus 3n, and whatever you do to one side, you have to do to the other. Okay? So on the left-hand side, I'm going to bring down 4m equals 8 and positive 3n cannot be combined because those two are not like terms. So I bring it down as an expression like this, 3n plus 8. All right, so m is the variable we want to isolate. M is not alone yet. We need to do the inverse of that multiplication. So let's divide by 4. Whatever you do to one side of the equation, you will do to the other. Okay, let me write it this way. I think this will help. When you divide an expression by a number, you divide each of the terms by that number. Okay, so m equals 3/4 n plus 2. And that's your answer. All right, number 2. Copy it down. 15 equals 3n plus 6p, and this one we're going to solve for n. N as in Nancy. So keep your eye on the n. That's the variable that you want to isolate. So let's start by subtracting 6p. Subtracting 6p. We'll subtract 6p from both sides. Okay. When you subtract on this side, you know that you cannot combine 15 and negative 6p. They're not like terms. So therefore, I need to bring it down as an expression. So we can bring it down this way. 15 minus 6p equals 3n. Now we want to divide by 3. And we'll divide each term on the other side by 3. And so we have 5 minus 2p is equal to n. Okay. All right, let's move along. Let's look at number 3. Number 3. Copy it down, please. K minus 2 divided by 5 equals 11j. On this equation, we are going to solve for k. Notice with me where k is. K is in a grouping symbol. You may not see a grouping symbol like a parentheses or bracket, but it's in a grouping symbol because it's part of this numerator. Okay, what makes that k group together with the minus 2 is this fraction bar. So how will we, or how can we eventually get k to stand alone, the first thing we have to do is undo the division by 5. So let me bring this down. K minus 2 divided by 5 equals 11j. Let me go ahead and switch colors to show you. So I'll take this side of the equation and multiply it by 5. And whatever I do to the one side, I have to do to the other. All right? So k minus 2 comes down equals 55j. All right? So 55j. Now remember, keep in mind I want to isolate k. What must I do? I must add 2. Whatever I do to one side, I do to the other. So k equals. And you have to ask yourself, can you combine 55j and 2? Are they like terms? And the answer is no, they're not. 55j is a variable term and 2 is a constant. So I have to bring it down as an expression. Okay, let's move along. Number 4, copy down. 28 equals t times r plus 4 in parentheses. And this time we're solving for t. So what's being done by t to t? It's being multiplied by r plus 4. And this is one term because it's in the parentheses. So I can simply divide by r plus 4. Whatever I do to one side, I do to the other. So here I go. It's 28 over r plus 4 is equal to t. And that one was quick. Okay? All right, moving along. This one is going to be a little complicated, but stick with me, and I think you'll get this. All right, copy down number 5. 3x plus 2y equals xz plus 5. And we're going to solve this equation for x. But notice, please, that we have x's on both sides of the equation in separate terms. Okay? So in order to solve for x, we first have to get x on one side, and then we need to isolate it. Okay? So let's first subtract xz from the right. Whatever I do to one side, I do to the other. Okay? So I'll bring down the 5 on this side, so we're done there. But notice that 3x and xz cannot be combined, so I have to bring it down as an expression. 3x minus xz plus 2y equals 5. Okay? I'll highlight the x's again just so that you can see that we're still have x's in two terms, and now they're both on one side of the equation. Let me subtract 2y from both sides and see what's left. We have 3x minus xz equals 5 minus 2y. Of course, 5 and 2y are not like terms, and I cannot combine those. So notice here that 3x and xz both have x as a common factor. It's as though x had been distributed to 3 and to z. So what we can do is we can factor out an x and rewrite it this way. X, open parentheses, 3 minus z, close parentheses, equals 5 minus 2y. Just to make you think for a moment, if you were to distribute the x, you would wind up with the expression above it. Okay? All right, let me just erase that. All right, now just recall the goal. The goal each time needs to be remembered. We want to isolate x. So what we need to do is we need to divide by 3 minus z, and then we're going to divide by 3 minus z. So x equals, oh, let me write it here because I don't have room there. X equals 5 minus 2y over 3 minus z. And that would be your solution. Okay, here is the formula for circumference. Circumference equals 2 pi r. Suppose we want to rewrite this formula, but instead of solving for circumference, we want to solve for r. So how would we isolate r? Well, what you would do is you would divide by 2 pi, and so c divided by 2 pi equals r, and that would be your solution. Try number 7 on your own. It's the volume formula. Volume equals length times width times height. And what you want to do is you want to solve for the width. Solve for W. Pause the video now for a moment and solve this equation for W. Okay, check your answer. Volume over length times height equals the width. That would be your equation for W. Okay. All right. The process of carrying units through a series of computations is called dimensional analysis. You will do a ton of dimensional analysis when you study chemistry in high school. So let's look at number 8. A car travels 100 feet in about 2.8 seconds. What is the velocity of the car in miles per hour? Well, let's see what they give us. They give us 100 feet in 2.8 seconds. They're giving us the rate, the velocity, the rate of speed in feet per second. And what we want to do is we want to have that same velocity in miles per hour. Okay? So what we need to do is we need to multiply the rate by conversion factors. And I'll do each one in a different color just to show you. So the first thing we need to know is how many feet they are in a mile. Because remember, I want to go from feet to miles. To convert from feet to miles, I need to know that 1 mile is equal to 5,280 feet. Okay? That's something you should know. You should know that by heart. So I'll write that conversion factor as a fraction. 1 mile over 5,280 feet. Okay? The other unit that I need to convert is I need to convert seconds to hours. Seconds to hours. How many seconds are there in each hour? Well, I know there's 60 seconds per minute and 60 minutes per hour. That's 3,600 seconds in an hour. So 1 hour equals 3,600 seconds. So that's the conversion factor that I need. I need 3,600 seconds is equal to 1 hour. Okay? Now, this is the fun part. When I multiply all of these, I'm not only going to multiply the numbers, I'm also going to carry the units through. Remember that when we're multiplying fractions, we're always allowed to cross-cancel any common factors. So, I'm going to cancel feet with feet, and seconds with seconds. And so I'm left with miles per hour, which I've written here for you, miles per hour. Now I go ahead and I can multiply my numerical portion of my dimensional analysis as I go across. 100 times 1 is 100 times 3,600 is 360,000. Okay, so on the denominator, we have 2.8 times 5,280, and that equals 14,784. And now we need to divide 360,000 by 14,784. Okay, so when I divide that, I get 24.3, and so we would round that to 24 miles per 1 hour. 24 miles per hour. And that's how we use dimensional analysis. Okay? All right, a little independent practice today as we need to practice solving these literal equations. I want you to do number 1, number 7, number 14. On this page, I want you to do number 1. Only 1. Okay? Tomorrow we will continue working with literal equations. We will practice a bunch of dimensional analysis so that you can feel confident with this lesson. Okay? God bless you. Have a great night. Don't forget to write down any questions that you might have, and we'll go over them tomorrow. Alrighty, good night.